Solving a dilemma with pre-commitment works when, given a commitment to cooperate or move first by one of the players, the other player's best response is cooperating. Roughly, solving with pre-commitment works when one of the players is trustworthy, not both. So here's an example, very practical example, followed by Pepperdine University, who acts as though they don't trust their faculty. I commend them for that. Consider ways for Pepperdine to get better teaching or research from its faculty. This is a unique problem. We haven't seen this before. We want to identify the players in this game. Suppose Pepperdine chooses whether to spend $1,000 to send Professor X to a conference in Las Vegas over Christmas break. So the players are going to be Pepperdine and the professor. Pepperdine chooses whether to professor chooses whether to spend $2,000 of effort to prepare a conference presentation. If Pepperdine chooses to send the professor to the conference, then both Pepperdine and the professor gain $3,000 of benefit if the professor chooses to prepare, but the professor alone gains $3,000 if the professor chooses to not prepare. He will give a poor talk, but still enjoy Las Vegas. So if choices are simultaneous, should Pepperdine send the professor to the conference? And then there's questions about cooperation and can they trust each other? But to make sense out of all of this, it's very helpful to skip right to forming the strategic form payoff table for the game. I'm going to do that with payoffs in thousands of dollars, since all of these figures up here, this $1,000 to send to the conference, the effort, and then the gains are all in thousands of dollars. So let's just consider all the possibilities. So first, let's look at the benefits. The only positive benefits here are if Pepperdine chooses to send the professor to the conference, then both Pepperdine and the professor gain $3,000 of benefit if the professor prepares, but the professor alone gains $3,000 if the professor chooses to not prepare. So if Pepperdine sends, that's his first row, then if the professor prepares, Pepperdine gains 3 and the professor gains 3. But if they send and the professor does not prepare, then the professor alone gains 3. So the only positive values are these 3s here. Those are the only benefits. Now, what are the costs? Sending to the conference cost $1,000. So if Pepperdine sends, they are out $1,000. And then finally, the other cost is the professor chooses whether to spend $2,000 of effort. So if he prepares, it's going to cost him $2,000 or 2 of effort. I left these uncombined so you can see where they come from. To go to the next side, we want to take 3 minus 1, which is 2, and 3 minus 2, which is 1. And then we have a complete strategic form payoff table. Now, consulting this table here, what should the players do? Well, notice that Pepperdine is better off with the first row than the second row here, but better off with the second row than the first row there. So Pepperdine does not have a dominant or dominated strategy of rows. However, the professor, notice that the 3 is less than the 3 is greater than the 1, and the 0 is greater than the -2. So Pepperdine is working with this professor who has a dominant strategy of not preparing. The second column is better than the first column. So we can strike out this column. It is dominated, and this is dominant. Given that choice, the best response for Pepperdine is to choose the second row. So we end up with a dominant solution of Pepperdine not sending to the conference and the professor not preparing. So Pepperdine not send and the professor not preparing a talk. Are there mutual gains from cooperation? Well, when they do the dominant solution, they're here. The mutual gains are up here with the Pepperdine sending to the conference and the professor preparing. Can Pepperdine trust the professor to cooperate? Well, if Pepperdine sends, the professor's best response is to not prepare. So They cannot be trusted to prepare, to live up to their agreement. Can Pepperdine trust the professor? Well, the agreement is this cell here. Can the professor preparing trust that Pepperdine will actually send to the conference? Well, if the professor prepares, the best response for Pepperdine is yes, to actually do what they say they're going to do and send them to the conference. So it turns out that the professor can trust Pepperdine. It's just that Pepperdine cannot trust the professor. So we have a prisoner dilemma because one of the parties is untrustworthy and they can't reach an agreement just by talking to each other. But it turns out having the other player be trustworthy makes it possible that this can be solved by pre-commitment. Now, how exactly does that work? We're going to consider both possibilities. Can the two cooperate by Pepperdine pre-committing to moving first? So if Pepperdine pre-commits to sending to the conference, the professor is looking between a 3 and a 1. They would rather have the 3 and they would not prepare. They would break their deal and be untrustworthy. It's not in their best interest to cooperate and be here. So this would not solve the prisoner dilemma if Pepperdine pre-commits. On the other hand, what would happen if the professor pre-commits to moving first? Well, if the professor pre-commits to moving first, he would consider his two possible choices. He would look for a rollback solution. If he prepares, he figures that Pepperdine is going to respond by sending to the conference, which would give the professor this 1. And if he chooses to not prepare, he figures Pepperdine would not send him to the conference, and that would leave the professor with this 0. This 1 is better than that 0. So the professor, in response to all this, would prepare. And then the best response of Pepperdine is to send to the conference. And that is the cooperative solution. So pre-commitment, by having the untrustworthy party move first, solves this prisoner dilemma.